Imagine a single machine, attended by nothing more than a boy, slamming down with the force of atmospheric pressure onto a disc of polished copper. And in the space of a single heartbeat, a perfect coin emerges, identical to the one before it, and the one before that, and the 70 that will follow in the next minute. This is the Soho Mint in Birmingham, England, the first steam-powered mint the world has ever seen, and the place where the very idea of what a coin should look like was reinvented from the ground up. But to understand why this factory exists, we must first understand the crisis that demanded it. By the 1780s, the copper coinage of Great Britain was in a state of utter disgrace. The Royal Mint had effectively stopped producing copper halfpennies and farthings. King George III had halted the official production of copper coinage back in 1775, and the government's coin presses had fallen silent. For the common people of England, the butchers, the bakers, the grocers, the labourers who needed small change to buy bread and ale, this was catastrophic. Without official coins, the economy of everyday life was grinding to a halt. And into that vacuum rushed the counterfeiters. Birmingham itself, that great engine of industry and ambition, was ironically one of the worst offenders. Several makers in the city were so brazen, so confident in the absence of law enforcement, that they hung signs above their doors reading, "All sorts of copper coins made here." By 1786, an astonishing 2/3 of all copper coins circulating in Britain were counterfeit. The genuine coins that remained were battered, clipped, worn smooth, barely recognizable as legal tender. Workers were being paid in debased metal. Shopkeepers were forced to accept coins they knew were fake because there was simply nothing else. The Treasury had tried flooding the market with new coins in the early 1770s, striking millions of farthings and halfpennies, but this only made matters worse. Counterfeiters simply melted down the genuine coins and recast them into 2 or 3 lighter fakes, multiplying the fraud. Britain's small change had become a national embarrassment. One man looked at this disaster and saw not just a problem, but an opportunity. And he had the means, the genius, and the sheer stubbornness to do something about it. His name was Matthew Boulton. Boulton was already one of the most powerful industrialists in England. His Soho manufactory, situated on the outskirts of Birmingham near Handsworth Heath, was the largest industrial complex in the world. It was a place of wonders, a vast enterprise producing everything from silver-plated goods to ornamental metalwork, buttons, buckles, and fine decorative pieces. Boulton had a genius for manufacturing, an obsessive eye for quality, and a partner whose name would become synonymous with the age of steam, James Watt. Together, Boulton and Watt had already transformed the mining industry with their improved steam engines. Now, in the mid-1780s, Boulton turned his restless mind toward coinage. His vision was ambitious and precise. He wanted to produce coins that were perfectly round, exactly uniform in diameter and thickness, with images stamped concentrically to the edge, faces polished to a high shine, and designs engraved by the finest artists he could find. He wanted coins so well made, so heavy with pure copper, that counterfeiting them would be economically pointless. The cost of the metal alone would approach the face value of the coin. And he wanted to do all of this, not with teams of sweating men hauling on ropes and levers, but with the disciplined, relentless power of steam. In 1786, Boulton took his first step. He struck 100 tons of copper blanks at the Soho manufactory for the East India Company. It was a trial run, a proof of concept, and it convinced him that a dedicated purpose-built minting facility was not only possible, but necessary. That same year, he recruited one of the finest engravers in Europe, Jean-Pierre Droz, from the Paris Mint. Droz was a brilliant craftsman who had developed innovations in die design and the segmental collar, a device that could emboss the edges of coins during striking. Boulton wanted his expertise, his artistry, and his secrets. In 1788, Boulton formally approached the British government with a proposal to mint the nation's copper coinage using powered machinery. He promised it would be cheaper, faster, and far superior to anything the Royal Mint could produce. Sample coins were ready by May, but the government was slow to act, painfully, maddeningly slow. The first official contract would not arrive for nearly 10 years. Boulton, however, was not a man to sit idle and wait. He began construction of the Soho Mint on the grounds of his estate, deliberately positioning it behind a cluster of garden buildings, his menagerie, tea room, fossil room, and laboratory, to keep the operation hidden for reasons of security. The mint was located barely 110 meters from the manufactory's main building, tucked away within Boulton's own gardens, shielded from prying eyes. Secrecy was essential. The techniques being developed here were revolutionary, and Boulton had no intention of letting competitors, or counterfeiters, learn his methods. The heart of the operation began with raw copper. Boulton purchased refined copper from a variety of suppliers, including Cornish mines in which he held shares. The copper arrived at Soho in ingot form, and from here it entered a meticulous sequence of processes that would transform crude metal into gleaming coin blanks. First, the copper was heated and passed through rolling mills. Boulton understood that hot copper rolled far more easily than cold, and he described the process in his own words. The copper was rolled when sufficiently hot until it reached roughly twice the thickness of the intended coin. Then it was rolled again through finely polished rollers, and again, each pass bringing the strip closer to the exact required thickness. Between passes, the strips were pickled and cleaned to remove oxidation and impurities. Before the final rolling, Boulton measured each strip with specially designed calipers, precision measuring instruments of his own invention, to ensure the thickness was exact. Workers were even supplied with gloves to prevent greasy fingerprints from contaminating the polished copper surface. Every detail mattered. Every fraction of an inch counted. The rolling mills were powered by a combination of water and steam. The Hockley Brook ran through the Soho estate and fed a mill pond, providing a head of water for a water wheel installed in the northern end of the manufactory complex. This water wheel drove the rolling mill stands and various polishing laps. But as the demands of the mint grew, water power alone proved insufficient. In 1788, Boulton installed a double-acting rotary steam engine, one of his and Watt's own designs, to supplement the water wheel and drive the blanking presses. The water wheel was then freed to concentrate on the rolling mills, and the number of roll stands was increased from 3 to 5. Once the copper strip had been rolled to the precise thickness, it was fed into the cutting-out presses, also called blanking presses. These were screw presses, but unlike anything that had come before. Traditional minting presses were fly presses, or balanciers, that required teams of strong men to swing heavy-weighted arms and force the screw downward. The effort was enormous, the results inconsistent. One coin might be struck perfectly, the next might be off-center, too shallow, or cracked from excessive force. Boulton's blanking presses eliminated this human variability entirely. The steam engine turned a large vertical shaft, which rotated a horizontal cam wheel. This cam wheel contacted an arm on each press, turning the screw to raise the cutting punch above the copper strip. At the same time, a pair of arms attached to the screw pulled chains that lifted pistons inside 4 cylinders, creating a partial vacuum beneath each piston. When the cam wheel released the arm, the atmospheric pressure pressing down on top of the pistons pulled the chains and spun the screw back downward with tremendous consistent force, punching a perfectly round blank from the copper strip. The strip was fed under the punch by hand, and the presses worked at a rate determined by the speed of the engine. The freshly cut blanks emerged with sharp edges from the cutting process. To smooth them, the blanks were tumbled, placed together in a rotating drum or barrel where they knocked against each other, wearing down the burrs and rough edges until each disc was smooth and ready for the final step. Now came the moment of transformation, the coining press itself. Boulton's coining presses were arranged in a circle, 8 machines surrounding the central shaft of the steam engine. A sketch from 1789 shows this elegant arrangement, the presses radiating outward like the spokes of a wheel, all driven by a single source of power. Each press was attended by just one boy, where traditional mints required 4 strong men, heaving and straining at each press. Boulton needed only a child to feed blanks and monitor the machine. A skilled man would occasionally attend to change dies, make adjustments, or perform maintenance, but the pressing itself was entirely mechanical. The lower die sat fixed in the bed of the press. The upper die was attached to the screw. A blank was placed on the lower die, and the press descended. Around the blank sat a collar, a steel ring that constrained the coin during striking. Levers held this collar level with the surface of the lower die until the upper die came down. A 3-leafed spring caused the collar to rise just as the blank was struck, so that the copper was squeezed simultaneously between the 2 engraved faces and against the lettered or ornamented edge of the collar. In one single precise blow, both faces and the edge of the coin were formed at once. The coin was then ejected, and the next blank was placed. 70 to 85 coins per minute, per press. 8 presses running simultaneously. The sound must have been extraordinary, a rhythmic thunderous percussion echoing through the hidden mint behind Matthew Boulton's garden. The dies themselves were works of art, and Boulton spared no expense in their creation. After Droz's departure in 1790, the Frenchman left under a cloud of mutual frustration, with Boulton calling him a quack who had been only learning at Soho and not teaching. Boulton hired the German engraver, Conrad Heinrich Küchler, in 1793. Küchler would go on to create some of the most iconic coin designs of the era. The dies were made from carefully selected cast steel, and Boulton went to extraordinary lengths to ensure their quality. Steel ingots often contained slag inclusions that concentrated at the top and center. Boulton had his steel bars forged square, cut into short slugs, then reforged into conical shapes, with the central axis rotated perpendicular to the original bar. This meant the engraving was done on a face far less likely to contain hidden flaws, a technique so effective that mints around the world continued using it for the next 150 years. In 1790, Boulton took out a patent for his coining apparatus, formally protecting the innovations he had poured years of effort into developing. But he was still waiting for the government contract he so desperately wanted. In the meantime, the Soho Mint was far from idle. Orders poured in from across the globe, trade tokens for British merchants, copper coins for the East India Company, coins for Sierra Leone, for the colonies, medals commemorating battles and monarchs. The mint's reputation for quality was unmatched. Finally, in 1797, the breakthrough came. Boulton signed a contract with the British government to produce the national copper coinage. The result was the famous Cartwheel penny and twopence, massive heavy coins that felt like real money in the hand. The penny weighed 1 ounce of pure copper, the twopence a full 2 ounces. They featured broad, raised rims with inscriptions pressed below the surface, a design Boulton believed would be extraordinarily difficult to counterfeit. Over 45 million of these coins were struck in just 2 years. For the first time in decades, British workers and shopkeepers had reliable copper coins they could trust. But Boulton was not finished innovating. The mechanical system, the cam wheel driving the presses through direct linkage to the steam engine, had proven somewhat violent in its operation. The motion was too harsh, too jarring for the delicate work of striking perfect coins. So in 1798, Boulton's brilliant engineer John Southern proposed a radical solution: abandon the mechanical drive entirely and power the coining presses using vacuum alone. Instead of a cam wheel turning the screws, the steam engine would now evacuate air from a long manifold pipe, called the spirit pipe, connected to each press through a complex arrangement of levers, rods, and balancing beams. Atmospheric pressure, acting on pistons connected to the presses, would provide the striking force. The beauty of this system was its smoothness and consistency. By maintaining a constant vacuum in the manifold, the force applied to every single coin could be precisely controlled. The new vacuum-powered mint was ready by December of 1798, and it came into full operation in March of 1799. The layout of the coining room was completely redesigned. Where the mechanical presses had been arranged in a circle around the central shaft, the vacuum-powered presses were now set in a line, each connected to the spirit pipe running beneath the floor. Adjustable counterweights on cast iron balance beams allowed the operators to fine-tune the striking force for different denominations. The original wooden beams were eventually replaced with fish-bellied cast iron beams of T-section, stronger, more rigid, more precise. The Soho Mint did not merely produce coins. It produced a revolution in the very concept of money. Before Boulton, coins were rough, irregular, handmade objects, each one slightly different from the next, easily faked, easily debased. After Boulton, coins became standardized industrial products, uniform, beautiful, trustworthy, and produced in quantities that would have been unimaginable a generation earlier. His innovations, steam-powered presses, vacuum-driven striking mechanisms, precision rolling, the raised edge collar, scientifically prepared dies, were adopted by mints across the world. Boulton supplied steam engines and coining machinery to the new Royal Mint at Tower Hill in London, and to mints in St. Petersburg, Copenhagen, Calcutta, and Bombay. A grand total of 600 million coins and medals were struck at the Soho Mint during its lifetime. 600 million perfectly round, precisely weighted, beautifully designed pieces of copper, silver, and bronze, each one a tiny monument to the power of steam, the precision of engineering, and the vision of one man who looked at a broken system and decided to build something better. Matthew Boulton died in 1809 at his beloved Soho house. His son, Matthew Robinson Boulton, continued to direct the mint, and eventually his grandson, Matthew Piers Watt Boulton, took over management until the mint was finally closed in 1850. The machinery was auctioned off. One of the original coining presses was purchased by James Watt and Company. Others were bought by Ralph Heaton II, who used them to establish the Birmingham Mint, carrying Boulton's legacy forward into the next generation of British coinage. Today, nothing remains of the Soho Mint above ground. The buildings are gone, the garden that concealed them long since vanished. But the coins survive, in museum cases, in private collections, in the pockets of history. And the principles that Matthew Boulton established in that hidden factory, behind his menagerie and tea room, that coins should be uniform, that quality should be uncompromising, that machines should do the work of men with greater precision and at greater speed, those principles still govern every mint on earth. Every coin you have ever held in your hand is a descendant of what happened here, in Birmingham, when steam met copper and the modern coin was born.